Hello, hello, hello.
Yes, sir. Yes.
Yeah. So what a time management. It's exactly the time we were
Yeah,
looking for.
yes. Yeah. Thank you so much, sir. Thank you so
Thank you,
much.
sir.
So can
Yeah.
you see my slides?
Yes,
Yes.
sir. I can
Okay.
see. Yes.
And
Yes, sir.
is
Full
there any
slideshow.
is there
Yes.
any formality or I can start?
Yeah, yeah. You can start, sir. I would request Professor Kapil Gupta, sir, to begin with the first session on harnessing the potential of additive manufacturing to shape a better world. Thank you.
Yeah. Thank you, Dr. Jaju. Good evening, ladies and gentlemen. Kapil Gupta here from University of Johannesburg. Currently, I am at Oman attending one conference here. So the title of my talk is Harnessing the Potential of Additive Manufacturing to Shape a Better World. So I request you to please accept, consider this talk as a message appeal to make contributions towards sustainable development goals. Although we are making contributions, but there is a need to document that contribution. So this is going to be the organization of my presentation. Number one is introduction, then additive manufacturing to shape a better world with the help of few examples, very common examples. I'll explain you how we can make contributions, how we are making contributions, my own contributions, contributions of University of Johannesburg. Then after that, facts and figures, what South African government is busy doing towards 3D printing or additive manufacturing, Indian government as well, and then conclusion and call to action. So this is about me. The introduction was already done. Let me brief quickly my specialization and expertise: advanced and sustainable manufacturing, special focus on these advanced machining processes. I'm also working in engineering education and fourth industrial revolution. About the research outputs, so 20 international books on various topics of advanced manufacturing and journal articles, conference articles, journal articles, Scopus, SCI, Q1, Q2, Q3. Professional services, so I am on the editorial board of 7 international journals, out of which 2 I am serving as associate editor, Journal of Process Mechanical Engineering Part C, and Journal of Mechanical Engineering Science, that is Part C, and Process Mechanical Engineering Part E of SAGE, IMechE. Around 7 PhD students I have supervised so far, and 16 master students and 5 postdoc fellows I have hosted. 4 PhD students and 5 masters are still under supervision, and I have attracted handsome funding from the Royal Academy of Engineering, UK, National Research Foundation, South Africa. I am also the rated researcher in C category, established researcher by National Research Foundation, South Africa. I am working in collaboration with many international companies and institutes, including CSIR Pretoria, Genmark Automation, South Africa and India, London Southbank University, Swansea University, IIT Indore, many other IITs and other renowned institutions. Professional memberships. So I'm professional engineering technologies by Engineering Council of South Africa. I am also a member of South African Young Academy of Science, South African Institute of Mechanical Engineering, Industrial Engineering, and South African Society for Engineering Education. So let's start this introduction. Very basic thing, manufacturing. So this manufacture, it has come from two Latin words, manus and factus, made by hand. It used to be made by hand, but these days it's mechanization, automation, and the intervention of digital technologies. So the economical and technological significance of manufacturing, technological significance of manufacturing is what, starting raw material, we give shape, size, dimension, and some form to that raw material so that it can become a process part. That is the technological significance with the help of various manufacturing operations. Now the starting raw material is having least value, so we do value addition by you know um, using manufacturing processes. So we add the value and make it a product of high value. So that is the economical significance of manufacturing contribution towards the gross domestic product. In South Africa, it is the GDP of South Africa is 370 billion USD. The Indian GDP is 3550 billion USD. So almost 13-14% contribution of manufacturing is towards GDP, and it has been consistent since last 3-4 years. More than 11% contribution is there. In manufacturing, we are just speaking the very basic things to lay a foundation so that we can jump to the additive manufacturing, 3D printing. So conventional manufacturing and advanced manufacturing. In conventional and advanced, there are 4 categories: subtractive, additive, and deforming. And 3D printing is one of the types of manufacturing technique. that is in additive category. There are other manufacturing techniques like surface property enhancement. So in subtractive we have finishing processes, in additive we have coating, and in deforming forming we have short and laser shock peening. Now, additive manufacturing, that is commonly known as 3D printing, although it's a sort of slang because 3D printing is one of the techniques of additive manufacturing, but in common use, we are calling it as 3D printing. So, what I believe is it is an important tool of Industry 4.0 and an important technique of advanced and sustainable manufacturing. So, the presentation is towards discussing advanced manufacturing, sustainable manufacturing, and 3D printing because it is an important tool of Industry 4.0 and an important technique of advanced and sustainable manufacturing. So, sustainable manufacturing, the best definition of sustainable manufacturing is the creation of manufactured products using processes that minimize negative environmental impacts, conserve energy and natural resources, are safe for employees, communities, and consumers, and are economically sound. The definition of advanced manufacturing which I could develop, there could be many possible definitions which I could develop, is advancements in manufacturing via incorporating intelligent, novel, and sustainable technologies with an aim to enable it to address the growing needs and fulfill the new requirements related to cost, quality, and sustainability. And 3D printing is making contributions towards attaining these new requirements. I would like to share two important facts. Manufacturing accounts for 12% of the world's global greenhouse gas emissions. And as per the article from Delft University of Technology, Netherlands, it is estimated that additive manufacturing can lead to a 5 to 27% reduction in global energy usages by 2050. Now, industrial revolution, it is also important to realize the journey from 1784 to today, Industry 1.0 to Industry 4.0, fourth industrial revolution, where the 3D printing, autonomous robots, simulation, these are some important tools of fourth industrial revolution. Industry 4, we can say, fourth industrial revolution or industrial revolutions are for all business processes, but Industry 4.0 is specifically for manufacturing. It's a subset. Industry 4.0 is a subset of fourth industrial revolution. The definition of fourth industrial revolution: the pervasive use of the artificial intelligence, Internet of Things, blockchains, big data, and 3D printing types of technologies to enable better, smarter, sustainable, and more efficient processes. So there could be many advantages, benefits of Industry 4.0, but two important benefits which I identified, like to save time, reduce wastages, enhance efficiency and safety, and increase profits, and to stay competitive globally. And 3D printing is one of the important tools of Industry 4.0. There are limitations. Number one is dehumanization of industrialization. So 3D printing is making space here and providing jobs. Job creation is an important aspect of 3D printing, and also environmental degradation is the limitation of Industry 4.0. So the sustainable practices are in place. 3D printing is also one of the sustainable techniques, how that we'll discuss, but it is also making contributions towards resolving this issue, that is environmental degradation. That is the limitation of Industry 4.0. Let me take you to the journey of Industry 5.0. So high demand of individualization. Generally, it's Industry 4.0, but we started feeling Industry 5.0 because it's an era of mass personalization. The very basic example, like there are various ice cream yogurt machines, and you go and you make your own yogurt, you put your own topping. Same for shoes design, whatever design you want, you can make the laces, the color, the sole. So this is the era of mass personalization, and 3D printing is making great contributions in Industry 5.0 as well. We have started thinking about the journey of Industry 5.0, where mass personalization, collaborative robots, which are called cobots, waste elimination, minimization, sustainable machines, intelligent processes, and renewable energy for operation are the key aspects, where waste elimination and mass personalization, 3D printing is playing big role. Very basic additive manufacturing classification and how it starts. So geometric modeling, tessellation, slicing, and the building of the final object. These are the stages in 3D printing. Additive manufacturing or 3D printing, the classification is liquid-based processes, solid-based processes, powder-based processes, where direct energy deposition is also in picture these days, like lens, laser engineered net shaping operations. And the main thing is like what, like from 3D model to physical object is just a task of a click. And defense, consumer goods, healthcare, electronics, automobile, aerospace, all sectors are getting benefited by this 3D printing. Now, additive manufacturing to shape a better world. So 3D printing, additive manufacturing, important technique of advanced and sustainable manufacturing. So what is a better world? There's a need to realize that better world, sustainable world, where equal opportunities, equal focus is on economic growth, social inclusion, and environment protection. When sustainability comes into mind, then the image is only environment. It used to be like that, that sustainability means environment, but after a certain period of the coining of this sustainability term, it was realized that it is not only the environment, it is also economy and society. So, like, the focus should be on people, profit, and planet. So, believing that in 2015, 17 sustainable development goals were set by United Nations General Assembly, where around 169 targets there, and it was assumed that by 2030 we would be having a better world. So what that better world? The sustainable world, where equal opportunities focus and concentration is on the economic growth, social inclusion, along with the environment protection. So there's a need to identify, there is a need to recognize which goal we are working on, and we can make contributions by our teaching, learning, and research activities. Some goals I have identified, I am pursuing these goals that I'll discuss with the help of some examples. But here it is also important to just have a look of sustainability. The very basic definition of sustainability is the ability to exist constantly, or the ability to continue a defined behavior indefinitely. The United Nations considers sustainability as sustainable development. Here, before that, I just wanted to share the three pillars, well-known three pillars of sustainability: economy, environment, and society. So if contributions are towards any of the pillars, then the contributions are towards making or shaping a better world, sustainable world. United Nations understand sustainability as sustainable development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And I believe that additive manufacturing can play a vital role towards sustainable development, because the process is beautiful, process is taking care of many aspects. It is also supporting society, economy, and environment. And University of Johannesburg supports the sustainable development goals. So additive manufacturing and SDGs for economic growth, societal development, and climate action. So goal number 3, good health and well-being, decent work and economic growth. Goal number 8, goal number 9, industry innovation and infrastructure, and goal number 12, responsible consumption and production. By 3D printing, we can contribute responsible production and consumption. So you know very well that 3D printing, less material is required. Industry innovation, infrastructure. So we are devising new solutions for whatever problem we are facing in 3D printing. That is a contribution towards goal number 9. Decent work and economic growth. We are harnessing the potential of 3D printing to make biomedical devices, products like COVID-19 pass. So COVID-19, we use 3D printing for development of shields, masks, and many other biomedical devices. So that contribution is towards United Nations SDG 8, decent work and economic growth, and many other examples that we'll pursue in the next slides. Good health and well-being, also biomedical devices. So that is also contribution towards the goal number 3, good health and well-being. But on top of that, what I believe is SDG 17, partnership for the goals, is a key, exploiting which we can make contribution towards other goals. So that is also going to be my message, that let's collaborate via SDG 17. And if we go ahead, then 17, 3, goal number 8, 9, and 12. So how they are written, what they basically consist of. So goal number 12, I'm not going into detail, but quickly I'll summarize. So responsible consumption and production, so minimizing the natural resources and toxic material used, and to strengthen the scientific and technological capacity to move towards more sustainable patterns of consumption and production. So there are many examples in advanced manufacturing, but this particular session is on 3D printing. So we'll see how 3D printing is making impact. Goal number 9, that is the industry innovation infrastructure. So to build resilient infrastructure, promote sustainable industrialization, and foster innovation, where there is a need to upgrade all industries and infrastructure for sustainability, to enhance research and upgrade industrial technologies. Now, this economic growth, social development, climate action, they are heavily dependent on investments in infrastructure, sustainable industrial development, and scientific and technological progress. So fund is required for that, but along with the fund, let's say we have received the fund, then we have to make interventions. So the interventions towards what? Towards the development in machine tools for ready manufacturing, material extraction, processing and fabrication, process variants and hybridization of 3D printing with machining processes, process optimization, intelligent monitoring and control, novel measurement testing and characterization techniques for 3D printed objects, energy and resource efficient materials, processing and manufacturing for 3D printing, and many other ways we can make contributions. We can devise solutions for 3D printing and by 3D printing to contribute towards SDGs. Now, additive manufacturing, economy, society, and environment. So it is making impact, like it is contributing towards job creation, so economy and society, also GDP contributions, contributing towards world GDP. Additive manufacturing for teaching, learning, engineering education. We'll see how, with the help of some examples. Eco-friendly practices are involved. Circular economic contributions are there. Reduce, reuse, and recycle concept, it supports very well additive manufacturing. Responsible and on-demand manufacturing is possible. So it is a responsible manufacturing technique, making contributions towards environment as well as towards economy. On-demand manufacturing. Cost-effective and time-efficient fabrication of complex products is very much possible by 3D printing. Shaping a better world continued. So here, society, how can we make contributions, or how 3D printing can be utilized to contribute towards goal number 3, 9, and 12, and also goal number 8. So number 1 case is, as I said, additive manufacturing for biomedical applications, whether we are developing new materials using various additive manufacturing techniques for making implants, or we are developing implants by 3D printing, or prosthetics or any other devices, then the contributions are towards good health and well-being. Making innovations, making new strategies to develop these products, then contributions are toward SDG 9. And certainly minimizing the consumption of fluids, minimizing the material usage, then the contributions are towards SDG 12. The other case here is 3D printing for engineering education. So whether it's DIY activities or makers space where students can make presentations, make models, and various gadgets and devices for various competitions, or it's project based learning where a conventional design approach is used to design a part product, followed by computer aided drafting, and then finally the 3D printing is used to make that product in reality. It's also used for prototyping in engineering education to make prototypes for the projects, and also for laboratory samples for testing and demonstration purposes. So here it is making contributions toward decent work and economic growth, SDG 8. I myself utilize it. A reference of one of my papers, you can see that I published in one conference proceedings, that is a book chapter. Now, the other one is economy. So on-demand manufacturing, we know one of the key ways that future printing technology is likely to impact the economy is through the rise of on-demand manufacturing. That reduces your inventory, that reduces your supply chain, manages supply chain very well. With the advent of 3D printing, it is becoming increasingly possible to produce goods quickly, cheaply, and on demand. So no expensive tooling or large-scale production runs are required. Inventory warehouses of less capacity can solve the purpose. So these contributions are towards SDG 9, industry innovation infrastructure and responsible production and consumption. Here, another example is related to topology optimization, where the infill pattern, different infill patterns can be used to reduce the waste and to minimize the weight of the 3D printed object. So minimize the waste means what? To minimize the consumption of the material and contribution towards SDG 9 and 12. Making innovations, different variety of shapes, infill patterns, then that contribution is SDG 9. Another example is the tool path optimization, the deposition path. So different deposition path, to optimize the deposition path in order to um, achieve the early fabrication of the part. So that is the time reduction in making 3D printed object. So the time reduction is leading to SDG 12, that is leading to SDG 8, economic growth. So these are the contributions in economical point of view 3D printing is making. Environment. So how 3D printing really helps accelerating the sustainable manufacturing. So there are lots of examples. That's why it is called the responsible manufacturing technique. Less material consumption and waste. Lighter, more efficient parts can be made by devising various infill strategies. Parts consolidation is possible, and no overproduction. So 3D printing can be more sustainable than standard manufacturing because less material, few machining operations. It creates smaller accounts of scrap. Lighter and often more geometrically flexible designs are possible, which are environmentally friendly. And it supports circular economy because the principle of circular economy is to reduce, reuse, and recycle. So we can explore the various other topics in order to increase the impact of 3D printing towards circular economy. I have shared some burning topics related to the current 3D printing research in my next slide. So it can greatly help to manage carbon footprints, and this environment related contributions are towards SDG 9 and SDG 12. So SDG 3, 8, 9, 12, and 17 are the SDGs which I could identify where we can harness the potential of 3D printing and make contributions. It is also very important to harness the potential of generative AI, especially the junior faculties and the students, for research and publications in additive manufacturing of 3D printing. AI generators, which work on large language models, and they can generate against the prompt given, they can generate the images, text, audios, and videos. So these are some important: Chat GPT, Sora, DALL-E, Google Gemini, Elicit, Research Rabbit, Quillbot, Grammarly, Pexel, FreePik, and many other AI generators. The only thing we need to keep in mind is the proper prompt engineering, which is the combination of role, task, requirements, and instructions. So the best prompt given, the best result you can draw from these AI generators. There's an issue also. So possible concerns related to generative AI usages: undermining the development of critical thinking, writing ability, and comprehension skills. For that, the user must be AI literate, must know the ethics related to AI, and skillful with AI. So these are very important aspects in this fourth industrial revolution era for making contributions, making societal impacts by conducting research and publications in additive manufacturing, exploiting the potential of these AI generators. Let's go ahead. Here, latest trends in additive manufacturing research and future directions where we can also collaborate. So properties of AM materials, they are recycling and new materials. Surface finish of AM parts is a big issue still. Volume and speed of printing, research related to that. Technology for weight reduction and nozzle design, etc. AI based additive manufacturing process monitoring, drive lifecycle engineering analysis of various additive manufacturing processes, sustainability evaluations, and machine learning for intelligent modeling and optimization of additive manufacturing process parameters. Uh, Almost the similar points in some other wording: support free building of part. It is also very important to devise solutions to make support free building of parts, strong parts with fine details. So research on topology optimization is required. Personalized lightweight products from digital form, etc., are still to be explored via 3D printing. So increasing build speed, low post processing requirements related to surface finish of AM parts, exploring resins and plastics, etc., made by material recycling, to use them for 3D printing. And 4D printing, where you are giving the fourth dimension, like so 3D printing objects can change their shape, size, dimensions, exposing to the different environment. So shape memory alloys and these type of smart materials are required for that. So it is also a very important topic for further research and in trend. Let me introduce to you some facts and figures. Additive manufacturing development in South Africa. So South Africa, GDP 370 billion USD, and global economic ranking 43. South African government is taking these sustainable development and advanced additive manufacturing in a green economy pathway. So it is a just transition to a resource efficient, low carbon, and pro employment growth path, where this green economy is one of the pathways to sustainable development and poverty eradication, and may ensure sustainable economic growth. So 3D printing is also an important tool for that, to strengthen the green economy initiatives. Before that, there are some other aspects like National Advanced Manufacturing Technology Strategy for South Africa is in place. National Advanced Manufacturing Innovation Awards are there. Additive manufacturing strategies there. We'll see what all is covered in this additive manufacturing strategy. Manufacturing competitiveness enhancement program is there, and Center for Fourth Industrial Revolution, where special focus is on IoT, blockchain, and ML, machine learning. Circular economy interventions are also there. Now, South African government has identified 9 priority sectors and areas, and these days the efforts are being made to make interventions of 3D printing technologies to support all these 9 priority sectors and areas by making solutions by various interventions. Now, here South African additive manufacturing strategy, it consists of mainly 4 focus areas: qualified AM technology for final part manufacturing for the medical and aerospace markets, then additive manufacturing technology for impact in the traditional manufacturing sectors, and new additive manufacturing material and technology development, and small and medium enterprise development and support programs. So this is about the South African additive manufacturing industry. Government is quite active here. Department of Science and Innovation is piloting the use of 3D printed homes. University of Johannesburg has the first university which printed the very first 3D printed home in South Africa. I'll show you the pictures later. Medical device additive manufacturing technology demonstration is in place with the collaboration of Central University of Technology for application of additive manufacturing for the production of customized medical implants. So this is about South African government. Now, additive manufacturing in India. So before jumping on the additive manufacturing contributions and the interventions of Indian government, some facts: that 42% of Indian population is of people aged between 15 and 35 years. These are basically millennials, Generation Y, and Generation Z Zoomers. World's 5th largest economy, and manufacturing contribution to GDP is 13 to 40%. National manufacturing policy of the government of India is in place and aims to increase the share of manufacturing to GDP by 25% by 2025. Government is pursuing United Nations Sustainable Development Goal, and there is a roadmap by Niti Aayog. So Swachh Bharat Abhiyan, Smart Cities, Make in India, Startup India, Digital India, these initiatives are there. And Digital India, Startup India, these are very much related to 3D printing and Make in India as well. Now, SDG India Index, ranking is there, where Kerala is the topmost, and Uttarakhand is the topmost states in India. Now, the Samarth scheme is there, the Smart Advanced Manufacturing and Rapid Transformation Hub, Udyog Bharat 4.0. National strategy for additive manufacturing is in place in India. World Economic Forum's fourth Center of Fourth Industrial Revolution is there in Mumbai, and common engineering facilities are there. Common engineering facilities, Center of Excellence are also there for 3D printing. I'll show you in the next slides. So Indian government is basically finding various ways to make societal impacts these days. Department of Science and Technology of Government of India. Now, with India's Atmanirbhar mission, self-reliance for manufacturing, several government agencies are now preferring made in India. So here we are finding the scope of 3D printing, where 3D printing can make defense components for various other fields like biomedical, and all under this Atmanirbhar mission of Government of India. Government of India has released a national strategy for additive manufacturing. Objective of that national strategy is to strengthen India's position in the global 3D manufacturing landscape, and to acquire a 5% market share and contribute almost 1 billion to GDP by 2025. So, and this national strategy is in partnership, collaboration with academia, government, and industry. And the targets are to 50 Indian specific technologies relevant to this 3D printing. 100 new startups are to be there. 500 products related to 3D printing are to be built. 10 existing and new manufacturing sectors are required to be established, and 1 lakh new skilled manpowers are required to be, or are intended to be trained. Awareness adoption of AM products is also on target. Government of India is set to build the Center of Excellence for Advanced Technologies, where 3D printing is going to be one of the important technologies. ATAL Innovation Mission is there, where ATAL Tinkering Labs are in place, where 3D printing is a well-known technique there. Various 3D printers are commissioned under do-it-yourself scheme, with do-it-yourself kits. Gujarat government has also signed the MOU with US Institute of 3D Technology and OEM 3D systems. Also, the Andhra Pradesh MedTech zone is there, which has collaborated with the Wollongong University for 3D printing biolab, and also Department of Heavy Industries Center of Excellence at ISC Bangalore, that is in collaboration with Wipro. Andhra Pradesh government is also collaborating with Hewlett and Packard. So these are some MOU based and collaborations where the focus is on 3D printing to excel in the era of fourth industrial revolution by harnessing the potential of 3D printing. The contribution of the University of Johannesburg. So we have short learning programs in place, 3D printing, various other additive manufacturing courses. Certainly, we have included additive manufacturing in our teaching. We are also pursuing Global Excellence in Stature 4.0 initiative, where our library is Library 4.0, and we have established a maker space there in our library equipped with 3D printers. Like I said, so 3D concrete printing at University of Johannesburg for affordable housing. So we have completed South Africa's first 3D printed building in 2023. The building looks like this, you can see. My own contributions. So I carried out some research on 3D printing, where topology optimization. My master student, or I also edited some books. I was the series editor of 4 books, where additive manufacturing book was an important volume. Also, in advanced manufacturing technologies, innovations in manufacturing for sustainability, we incorporated some 3D printing based chapters. Now about the University of Johannesburg. So we have 8 faculties. Faculty of Engineering and Built Environment is out of the 8 faculties, which has 13 departments under 5 schools. My school is School of Mechanical Industrial Engineering, and my department is Department of Mechanical and Industrial Engineering Technology. Please ignore this Department of Industrial Technology. It is my own department, that is the mix of mechanical and industrial engineering. Now the ranking of University of Johannesburg, QS ranking 312 times ranking. We are in between 401 and 500 position, and the recent very latest last few days, 2-3 days, Sub-Saharan Africa ranking. So University is Johannesburg is at the topmost position. This is the aerial view of my campus. Out of the 4 campuses of University of Johannesburg, we are running BNG Tech qualification of 3 years, and 4 year we provide honors, we award honors. We have master's and doctoral degree courses as well, and we have the research groups, advanced metal processing manufacturing, industrial engineering, quality and management, energy systems and infrastructure, industry 4.0 and sustainability, engineering education, and all the state-of-art facilities available. There are a few pictures of my campus. My campus is the smallest campus of University of Johannesburg out of 4 campuses. I'm a little bit fast because I have to join a function down there in the conference which I'm attending. So sorry for that. Now the vision and mission of University of Johannesburg. So to be an international university of choice anchored in Africa and the global south, dynamically shaping a sustainable future. Our mission is to transform and serve humanity through innovation and the collective and collaborative pursuit of knowledge. Our values are impact, innovation, inclusivity, integrity. Where we make a difference is what we stand for. We reinvent the future. We see inclusivity as a strength. We earn trust through integrity. Now, our strategic plan 2035, that is aligned with the United Nations Sustainable Development Goals, where three key pillars are there: societal impact and sustainability, where my university is committed to driving positive change by tackling issues such as inequality and environmental sustainability through innovative research and education. Global footprint and partnership. So we aim to strengthen international collaborations with universities, industries, and government to enhance knowledge, sharing, innovation, and global influence. And uh, we are exploiting, harnessing the potential of fourth industrial revolution to develop the future technology. And we are dedicated for societal impact through academic excellence, innovation, and community engagement. This is the corporate video of University of Johannesburg. I hope we have time, and I think I should play it so that I can introduce my university to you. If you don't, hear the sound, then please remind me.
There's a future at our doorstep, one where old concepts are being challenged, where accepted ideas are being tested, where unknown opportunities.
Dr. Jaju, is the volume and sound okay?
Yes, sir. Yes, sir. It is
Yeah,
okay. Okay,
let me
sir.
play from the beginning. Sorry.
Our doorstep, one where old concepts are being challenged, where accepted ideas are being tested, where unknown opportunities will crystallize, and fundamentally different perspectives hover at horizons that beckon exploration. And there's a path to that future, a way forward for Africa, a route of accomplishment for a new generation. It's a road towards understanding and knowledge, where the tools are to be found that enable us to build on the old, to harness the new, to fully embrace the digital universe which we are beginning to inhabit. This is what we do at the University of Johannesburg, UJ, where the whole is far greater than the sum of its parts. We have a vision to be an international university of choice, anchored in Africa, dynamically shaping the future. Our mission is to inspire our community to transform and serve humanity, innovation, and the collaborative pursuit of knowledge. And it's our values that underpin everything we do. And the first of those values, the one on which we build, is imagination. It's through imagination that we learn together from our diversity. When in 2005, 3 institutions became one, it was more than just a change of name. We took on the essence of the economic hub of Africa, Johannesburg, vibrant, dynamic, and like us, paving the way in a new South Africa, reimagining tomorrow. Our teachers, thought leaders, and mentors, our distinguished visiting professors, and our commitment to world-class research are leading the way on our continent with a strategy for global excellence and stature. Here at UJ, on our 4 campuses, we're exploring a multidisciplinary approach, a technologically empowered system of learning and teaching, investigating overlapping disciplines from the real impact of early childhood development to the virtual space of artificial intelligence, process automation, and smart cities to the development of nanotechnology that removes pollutants from water. We're interrogating the sustainability of global resources through earth sciences, looking deep into our past to see a future that we can help shape. We have 43 specialized research centers that include the Center for Education Practice Research, the Graduate School of Architecture, the Institute for Intelligent Systems, the Institute for Pan-African Thought and Conversation, the Johannesburg Institute for Advanced Study, the UJ Confucius Institute, and the Center for Private International Law in Emerging Economies. And all of this at the cusp of the 4th Industrial Revolution, 4IR, that demands a new perspective, new modes of thinking and doing, new ways of working together, new techniques for research, and new partners for collaboration. We understand with a deep-seated conviction that 4IR is the future that we will learn as we teach it, a future that means teamwork, collaboration, and partnership in research, implementation, and the application of knowledge in the workplace of tomorrow. That's why we're leading in research in many fields, including artificial intelligence, transformative innovation, cybersecurity, cyber law, and at our African Center for Evidence, the use of technology for evidence synthesis. We're cosmopolitan. Each of our 4 campuses has a student center equipped with meeting places, restaurants, cafeterias, recreational facilities, and even shops for added convenience, giving them the feel of independent villages in the city. Some of our student centers house banks, bookshops, medical doctors, hairdressers, gift shops, and a supermarket. Staying in a UJ residence is an extension of the education we offer, with accommodation that ranges from residences to fully equipped apartments. Among our innovations, we offer first of its kind, fully online accredited qualifications in educational management, information and communication technology, public health, public management and governance, international accounting, human resource management, and financial markets. And as we move into the future, this list will continue to grow. Conversation. It's the value that underlies our learning together from our diversity, that underpins our determination to make wise decisions collectively, to engage meaningfully with one another in mutual respect, so that we can lead consultatively. Regeneration is the value that lets us develop sustainably through creative contribution to and by our staff and students for the society we want to build in South Africa and our wider continent, and for the benefit of a world changing before our eyes. It lets us look inward for renewal and fosters innovation for the common good. It guides us as we seek to make a positive change and to uncover and realize overlooked opportunities. But the value that embraces all our efforts, all our vision for the future, and all our commitment to our students, society, and continent is our ethical foundation. It is through this value that we treasure academic freedom and seek balance in our pursuit of knowledge. It gives us the strength to face our challenges with courage, to earn trust in others, to act responsibly, fairly, consistently, and transparently, to participate in our community, to practice that quintessential South African quality of Ubuntu, the humanness that makes us what we are and enables us to create what we know we can be. As we teach, wonder, question everything, learn willingly, and bring the fruits of our research to the edge of a new future, providing all those who undertake this journey of knowledge with us with the tools we need to create tomorrow. The University of Johannesburg, the future reimagined.
Yeah, thank you so much for your attention. Let's go ahead. So challenges are many. Our sheer size and rapid pace of our growth are the two biggest challenges. Lack of awareness, interest, and engagement tendency, working beyond the comfort zone, paucity of time, funding. This is I'm talking about overall contribution towards additive manufacturing, or whether you would like to harness the potential of any technology. So these are some challenges: absence of collaborative efforts, low intensity of research. But there are opportunities. Number one is better together in shaping a better world. So better together. Local and international collaborations, partnership for the goals via SDG 17, youth empowerment and upskilling in 3D printing, additive manufacturing area, integrating SDGs and additive manufacturing into teaching and learning and research development innovations, plans, policies, funding, scholarships, and interdisciplinary engagements. I would like to conclude that 3D printing has a potential to strengthen the three pillars of sustainability in economy, society, and environment. My call to action is let's collaborate via SDG 17 to shape a better world to achieve the excellence and sustainability. I would like to finish with a few beautiful lines of the French philosopher and journalist Professor Carr. Some people grumble that roses have thorns. I'm grateful that thorns have roses. Thank you so much for opportunity and listening to me. Dr. Jaju, I would only be able to take one
Yeah.
or two questions or comments. One or two.
Yes, yes, yes. No problem. Participants are requested to put your question in the chat box so that I will unmute those participants, or I will read the question for Professor Kapil Gupta, sir.
Is there any question?
We'll wait for 1 or 2 minutes.
All right. Yeah.
To pop up if they have any, because they are being muted basically, sir.
Yeah, it's
So,
all right. It's all right.
Sir, yeah. There is one question from one of the participants, Dr. Y.M. Sonkhaskar. Sir, what is the scope of 3D printing using flexible material?
Yeah, so the scope like 4D printing. Now let's talk about 4D printing, flexible material, smart material, shape memory alloys, and other smart materials. So scope is, very broad, very wide scope is there to make the robot arms in robotics specifically. Grippers.
Yeah. One more question is from Mr. Praveen Dhandore. As a PhD scholar, which are the new areas that are available to work?
Yeah, so number one new area which I would recommend always is this aligning 3D printing or additive manufacturing with sustainability. So like I have identified 4 or 5 goals. You can also identify, like let's say 3D printed turbine blades, windmill blades. So if you are using that, then you can also support, or you can claim that you are contributing towards goal number. What's that goal that is related to affordable and clean energy? Let me quickly take you to that particular goal slide. So here is the slide, and that is the goal number 7, affordable and clean energy. So goal number even in fact 11, sustainable cities and what is that, communities. So this is the area where you can make innovations, you can carry out research. And other is 4D printing is there. And on my that latest trend area slide I have shown. So I would recommend that please start with the very basic thing, the crucial fundamental research that is ongoing, topology optimization and these, and then jump on the sustainability interventions. Last question.
Thank you so much.
Last question.
Yeah, last question from Muthu Kumar. Throw some inputs on design for 3D printing and natural fiber reinforced composites.
3D printing and natural fiber reinforced composites. So composite development is possible these days. That is also thanks for kind of metals alloys that can be extruded like PLA used for FDM processes. Yeah, metals alloys, they can be even metal matrix composites are also possible by 3D printing, like selective laser sintering and these type of 3D printing technologies. These are possible these days. So I think.
Thank you so much, sir. So people who have asked the question, they have thanked you for answering their queries, and I think they are satisfied. And that was a wonderful session from you, even though you were busy at the another place in Oman, and you have means spare the time for guiding us. So the one last question is, are there metal extruders available, sir? Dr. A. Sri Harsha, are there metal extruders available?
Yeah, metal extruders are also available. That is also an important topic of research, like nozzle design. So one of my postdoc carried out that nozzle design thing. So metal extruders are available, and one has to, make some interventions for the nozzle design so that the wear and tear should be as less as possible. And these are the current trends where one can make interventions and excel in this 3D printing thing. Metal extruders are there. Yeah. So now there is a need to develop some more extruders which are made of hybrid materials, so that one can make contribution towards sustainability by minimizing the wear and tear. So that is also going to be a contribution. Nozzle, less wear and tear of the nozzle, as less as possible, as minimum as low as possible, as minimum as possible. So that can also be a very beautiful future research area.
Yes.
Yeah. Thank you so much,
So,
everyone.
yeah, thank you so much, sir. Thank you so much. On behalf of GHRCE College of Engineering, Nagpur, and on behalf of all the participants, I thank Professor Kapil Gupta, sir, from University of Johannesburg, South Africa, for sharing his knowledge with us. And hope participants will continue this journey in 3D printing and carry forward this research and align themselves in with the UN sustainability goals. So thank you so much, sir. Thank you so
Okay.
much.
Bye-bye. Thank you.
Yeah, thank you. Bye-bye, sir.
Thank you, Dr. Kapil Gupta,
Yeah.
sir, for enlightening the session on harnessing the potential of additive manufacturing to shape a better world. The insights shared by you today have truly highlighted the transformative impact of additive manufacturing across industries and its potential to drive the innovation for a sustainable future. Once again, thank you for your valuable time and contribution.